On question number 8, we are trying to minimize 5x plus 3y. So that is our objective function. And we have these constraints. So we need to graph each of these constraints so we can find the feasible region. So to graph these, we need to isolate for y. So 2x plus y is greater than or equal to 10 if we subtract 2x from both sides. We can graph this. 3x plus 2y is greater than or equal to 17 if we subtract 3x from both sides and then divide everything by 2. We get negative 3 over 2x plus 17 over 2. And then lastly, x plus 2y is greater than or equal to 7. I want to subtract x from both sides and then divide everything by 2. So negative 1/2 x plus 7 over 2. And then finally we have y is greater than or equal to 0. Now I'm ready to type these in on the calculator. So if we go to y equals and type them into y1 through y4 and then press graph, this is what our graph will look like. So now I'm ready to do the shading, and I like to do the reverse because I think it's easier to see. And each of our inequalities were greater than or equal to. So that would actually be shading above the upper triangle. But because I'm doing the reverse, these are all going to be lower triangles. And then press graph, and this is what our graph looks like. So our feasible region is actually all of this. And this actually continues forever. So this goes all the way to infinity. So this is something that's called an unbounded feasible region. So this will continue on to infinity. So actually the point, like if you plug in 9,999, 9,999, that actually works in all of our original inequalities. So that satisfies all of our constraints. However, our problem is trying to minimize. So we don't really care. We're looking for the minimum value. So we are searching for these corner points here, and one of those is going to give us the minimum. So let's remove the shading. So I want to change all of these back to the line symbol and then graph it, because that will make it easier to find the intersection points. Before we find the intersection points, I do want to graph this on my paper. So my graph is going to look something like this, and my feasible region was here. So my corner points are here, here, and then these two. So I have 4 corner points that I need to find. I want to use the intersection command on my calculator to find the corner points. So I need to do second calc or trace to get to the intersection command. And let's find this point first. So I need to select this line and this line as my two lines. And again, pressing up and down on the arrow key, that changes the line that your cursor is on. Pressing left and right navigates the current line. So my cursor is on Y1, so that is one of the lines that I'm looking for. So I'm going to press enter. So that has this line locked in. And now my cursor is on Y2, which is the other line that I'm looking for. So we can press enter, and then we can make a guess, press enter, and then it finds the intersection point 3, 4. I want to use the intersection command again. So second calc, intersect, and this time I'm trying to find this intersection point. So I want to select this line and this line. So my cursor is not on the correct line. So again, up and down, that changes the line that you're on. So if we press down, we get onto Y2, which is one of the lines that I'm looking for. So we can press enter to declare that as our first line. And then Y3 is what we want for our second line. So we have our first line declared. Now we're going to press enter to declare that as our second line. And then we can make a guess and press enter. And then we find that the intersection point is 5, 1. We need to use the intersection command for a third time to find our next corner point. So we're trying to find this point here, which means we need to declare this line and this line, which I believe are Y3 and Y4 that we entered into the Y equals menu. So right now the cursor is on Y1, so that's not what we want. So if we press down, it goes to Y2, press down again, it goes to Y3. So that is one of the lines, so we can press enter. So now it's on Y4, so that is our second line that we want, and we want to press enter. And then we can make a guess, and then the intersection point is 7, 0. The last corner point is on the y-axis. So to find that using the calculator, we can do second calc and then the value command. So it wants us to enter in a value for x. We're going to type in x is equal to 0 and then press enter. And then if we press up and down, it will scroll through all of the different points that are on the y-axis. Now my calculator immediately went to the one that we want, which is the one right here. So that is 0, 10. Now that we found all of our intersection points, we can label them as the corner points on our graph. So 0, 10, 3, 4, 5, 1, and 7, 0. So these are the 4 candidates for the minimum. So I want to plug them into the objective function 5x plus 3y. So 5 times 0 plus 3 times 10 is 30. 5 times 3 plus 3 times 4 is 27. 5 times 5 plus 3 times 1 is 28. And 5 times 7 plus 3 times 0 is 35. So they are looking for the minimum. So the lowest value is 27. So our final answer is the min is 27, and this happens at 3, 4.